Standing at the base of a massive stone block in Baalbek, Lebanon, you crane your neck to take in its staggering size, some weighing over 800 tons. That's heavier than 3 blue whales. Now picture this, thousands of years ago, without cranes, without computers, without even the wheel in some cases. Ancient builders moved these monoliths with impossible precision, fitting them together so tightly you can't slip a sheet of paper between the seams. How? That's the question that haunts archaeologists, engineers, and historians alike. These structures, Stonehenge, the pyramids of Giza, the walls of Sacsayhuamán, aren't just relics of the past. They're puzzles, and the deeper you look, the more they seem to whisper secrets about a forgotten chapter of human ingenuity. What if the stories we've been told about these megalithic wonders are missing something crucial? What if the ancients possessed knowledge or even technology that we've yet to fully understand? This isn't about aliens or magic. It's about re-examining the evidence with fresh eyes. The so-called blueprints of the gods aren't just myths, they're a challenge to our assumptions. Think about the Great Pyramid, aligned to true north with an error margin of just a fraction of a degree. Or Puma Punku's stone blocks, cut with geometric perfection that would stump modern stonemasons. These aren't accidents, they're the work of minds that saw the world differently and built accordingly. So let's take a journey together, one that spans continents and millennia. We'll explore the hidden logic behind these ancient marvels, from the celestial alignments woven into their designs to the tantalizing clues suggesting lost techniques. Were they using sound to levitate stones? Did they have access to tools we've never discovered? Or is the answer something even more profound? By the end of this video, you won't just see these structures as static monuments. You'll see them as messages waiting to be decoded. The past is speaking. Are you ready to listen? The sheer scale of megalithic structures scattered across our planet raises an irresistible question. How could cultures with no apparent connection build such strikingly similar monuments? Take the dolmens of Europe, massive stone tables perched atop upright slabs, and compare them to the hauntingly similar structures in Korea or India. Then there's the precision-cut polygonal masonry, found in both the Andes and ancient Greece, where stones interlock like jigsaw pieces without mortar. These parallels span continents and eras, separated by thousands of miles and years. Yet the designs echo one another with eerie consistency. Some argue this is simply convergent engineering, that humans, faced with the same challenges of moving and shaping stone, arrived at similar solutions independently. But others point to the precision, the angles, the astronomical alignments, the way these stones defy erosion and earthquakes. Could it be coincidence, or is there a deeper thread connecting them? Consider the possibility of a shared and lost source of knowledge. Ancient seafaring cultures like the Phoenicians or a yet unknown civilization could have spread these techniques. Alternatively, perhaps early humans discovered universal principles of geometry and physics, applying them in ways we're only beginning to grasp. The fact that so many of these sites align with solstices or celestial events suggests a sophisticated understanding of the cosmos, one that transcends cultural boundaries. From the towering menhirs of Karnak to the labyrinthine walls of Ollantaytambo, these structures challenge our timeline of human progress. Were they the work of isolated societies or fragments of a forgotten global tradition? The stones don't speak, but their patterns tell a story, one we're still deciphering. The precision of ancient stonework isn't just impressive, it's borderline inexplicable. Take the granite blocks of the Egyptian pyramids. cut and placed with joints so precise they'd make a modern engineer double-check their laser levels. Or the andesite stones at Puma Punku, where intricate notches and grooves interlock with micrometer-level accuracy, as if machined by industrial tools. How did cultures working with copper chisels and stone hammers achieve what we'd struggle to replicate today, even with diamond-tipped saws and computer-guided milling machines? One theory points to patient, painstaking abrasion. Imagine teams of workers grinding stone against stone for months, using sand or quartz as a natural abrasive to slowly wear surfaces into perfect alignment. It's possible, but when you examine the scale of some projects like the 1,000-ton blocks at Baalbek, the timeline becomes mind-boggling. Would generations really dedicate their lives to polishing a single slab? And what about the absence of tool marks on certain stones, like the mirrored surfaces of some Inca walls? Abrasion leaves traces, yet these stones look almost melted. That's where fringe theories creep in. Could ancient builders have harnessed vibrations or sound waves to soften stone temporarily, molding it like clay? Experiments with resonant frequencies show that materials can become fluid under specific conditions. Then there's the curious case of vitrification, the glass-like sheen found on some megaliths as if exposed to extreme heat. Were they using focused energy sources like sunlight amplified through lenses or some lost chemical compound? Even mainstream archaeologists admit we've likely forgotten techniques. The Romans, for instance, used a plant-based mortar so durable it still holds their structures together 2,000 years later. What else has slipped through the cracks of history? Perhaps the most humbling thought is this: precision engineering might not have been a technology in our sense at all. Oral traditions from Peru to Polynesia speak of ancestors who understood the spirit of stone, working with its natural grain rather than forcing it. Modern stonemasons sometimes describe a similar intuition, a feel for the material that transcends measurement. Could the ancients have combined this tactile wisdom with geometric principles we're only now rediscovering? The stones themselves hint at answers if we're willing to listen beyond our assumptions. Imagine standing in the center of Stonehenge at dawn on the summer solstice. As the first rays of sunlight pierce through the towering stones, they align perfectly with the heel stone, casting a long, deliberate shadow across the inner circle. This isn't random, it's a meticulously planned celestial event, encoded into the very bones of the structure. Across the world, from the pyramids of Giza to the temples of Angkor Wat, ancient builders embedded these cosmic connections into their designs. The question isn't just how they did it, but why. The answer might lie in sacred geometry, a language of shapes and ratios that repeat throughout nature. Take the golden ratio, a mathematical proportion found in everything from seashells to galaxies. At the Great Pyramid, the ratio of its height to half its base length is strikingly close to this divine number. Coincidence unlikely. Then there's the Fibonacci sequence, a spiral pattern seen in plant growth and hurricane formations, mirrored in the layout of sites like Teotihuacan, where temples and pyramids follow this natural progression. These aren't just aesthetic choices, they're deliberate echoes of universal patterns, as if the builders were tapping into a hidden blueprint of the cosmos itself. But the alignments go beyond mere mathematics. At Newgrange in Ireland, a narrow passageway floods with sunlight only on the winter solstice, illuminating a chamber deep inside the mound. In Choco Canyon, New Mexico, spiral petroglyphs mark where sunlight and shadows interact during equinoxes. These sites weren't just monuments, they were instruments calibrated to track time, seasons, and even longer cycles like the precession of the equinoxes, a 26,000-year wobble in Earth's axis. How did cultures separated by oceans and millennia share such precise astronomical knowledge? Some scholars suggest these alignments served practical purposes, agricultural calendars, or ceremonial markers. But others propose something more profound, that these structures were portals of a sort, designed to harmonize human activity with celestial rhythms. The Maya, for instance, built their pyramids to resonate with Venus's cycles, tying their rituals to the planet's appearances. In Egypt, the shafts inside the Great Pyramid point to specific stars, possibly guiding the pharaoh's soul to the afterlife. Whether as clocks, temples, or cosmic maps, these sites whisper of a world where earth and sky were inseparable, a dance of stone and starlight we're only beginning to understand. The deeper you look, the more these patterns reveal a startling truth. Our ancestors didn't just observe the heavens, they conversed with them and the stones they left behind. Perhaps they're not just silent sentinels of the past, but invitations to look up and remember. Walking through the ruins of Sacsayhuaman in Peru, you can't help but run your fingers along the zigzagging walls, each stone a unique, irregular shape, yet locked into its neighbors so perfectly that not even a blade of grass could squeeze between them. This is polygonal masonry at its most bewildering. Unlike uniform bricks, these stones look like pieces of a colossal jigsaw puzzle, some weighing over 100 tons, with edges that curve and angles that defy simple measurement. How did ancient builders achieve this without modern tools or even written blueprints? The answer might lie in a blend of ingenuity, patience, and techniques we're only beginning to grasp. One compelling theory suggests they used a method called sighting and trial fitting. Imagine a stonemason carefully shaping a block, then hauling it into place to check the fit, marking where adjustments were needed, and repeating the process over and over. It sounds tedious, but the results speak for themselves. At Ollantaytambo, another Peruvian site, you can see unfinished blocks with these very markings, frozen in time as if the workers stepped away mid-task. Yet this raises another question. How did they move these behemoths into position for test fittings? Some researchers propose they used log rollers, ramps, or even counterweight systems, but the logistics still boggle the mind. Then there's the mystery of the stone's surfaces. Many show no tool marks at all, their faces smooth as if polished by something far more advanced than copper or stone tools. This has led to fringe theories about ancient stone softening techniques. Legends from the Andes speak of a plant-based liquid that could temporarily make rock pliable, almost like clay. While no such substance has been found, experiments with organic acids show certain plants can indeed weaken stone surfaces, making them easier to shape. Could the ancients have discovered this by accident? Or perhaps they harnessed vibrations using resonant frequencies to liquefy stone momentarily, a phenomenon modern science acknowledges as possible under specific conditions. But the most humbling realization is this: polygonal masonry isn't just about brute strength or secret technology. It's about an intimate understanding of geometry and physics. The irregular shapes actually make the structures more earthquake-resistant, as the interlocking pieces shift and settle without collapsing. The Inca, and likely their predecessors, didn't just build walls, they engineered them to last millennia. Whether through lost techniques, painstaking trial and error, or a combination of both, these builders left behind a silent challenge to rethink what we assume about the past. Their stones don't just fit together, they fit into a larger puzzle of human capability we're still piecing together. Picture a block of stone the size of a small house, 800 tons of solid rock, being dragged uphill through dense forests or across deserts without wheels or metal tools. This isn't fantasy, it's the reality of the Baalbek trilithon, one of the heaviest objects ever moved by human hands. Conventional archaeology suggests log rollers, sledges, and armies of laborers, but when you crunch the numbers, the explanations start to unravel. Even with thousands of workers, how could they coordinate the movement of something that outweighs a Boeing 747 without modern machinery? The friction alone would crush wooden rollers into splinters. Some researchers point to ancient ingenuity with leverage and counterweights. The Egyptians might have used water-soaked sand to reduce friction for sledges, as depicted in tomb paintings. But for the megaliths of Baalbek or the Moai statues of Easter Island, dragged miles across jagged terrain, the challenge multiplies. Here's where the theories get intriguing. Indigenous legends speak of stones walking to their sites, guided by priests or supernatural forces. Could there be a kernel of truth buried in these stories? Experiments with vibration and acoustics offer tantalizing clues. Modern physicists have shown that specific sound frequencies can reduce friction, making heavy objects seem lighter, a phenomenon called acoustic levitation. Tibetan monks claim their ancestors used chanting to move stones, and Spanish chroniclers wrote of Inca builders employing thunderous instruments to position blocks. Then there's the mystery of magnetism. Certain megalithic sites sit atop deposits of magnetized rock. Was this coincidence, or did ancient engineers harness Earth's magnetic fields to assist in transportation? The most compelling evidence might lie in the scars left behind. At sites like Gerbeckly, Teep, massive stones were quarried and moved before the invention of agriculture, let alone pulley systems. Their transport routes show no signs of ramps or drag marks, just smooth pathways. Whether through lost physics, collective muscle, or something we've yet to imagine, one thing is clear: our ancestors turned the impossible into routine. And that realization forces us to rethink not just how they built, but who they were. Legends from across the ancient world tell of tools and techniques that defy conventional understanding. The Vedas of India describe Vamana's mythical flying machines, while Egyptian texts speak of the rod of destiny, a device said to cut stone like butter. Even Plateau hinted at lost knowledge from Atlantis, suggesting civilizations before us mastered arts we've yet to rediscover. But how much of this is myth, and how much might be rooted in reality? Modern experiments are beginning to blur the line between the two. Take the accounts of sonic levitation. Tibetan monks still chant ancient hymns they claim once lifted massive stones into place, and Spanish chroniclers documented Inca priests using thunderous instruments to maneuver blocks. These stories sound fantastical until you examine the physics. In 2014, researchers demonstrated how sound waves could suspend small objects in midair, a phenomenon called acoustic levitation. Scale that up, and suddenly, the idea of vibrating stones into position doesn't seem so far-fetched. Then there's the curious case of the Coral Castle in Florida, where a single man, Edward Leedskalnin, claimed to have moved hundreds of tons of coral rock using the secrets of the pyramids. Though he never revealed his methods, engineers remain baffled by how he achieved such precision working alone. The absence of construction debris at sites like Puma Punku or the Great Pyramid only deepens the mystery. Where are the chipped fragments, the broken tools, the trial and error waste we'd expect from massive stoneworking projects? Instead, we find finished blocks with almost surgical precision, as if cut by something far more advanced than copper chisels. Some researchers propose the use of high-temperature tools. Imagine a focused beam of sunlight, amplified through lenses or reflective plates, capable of softening stone momentarily. Others point to chemical compounds like the plant-based liquid stone described in Andean legends, which could have temporarily altered the rock's properties. Perhaps the most provocative question isn't whether these technologies existed, but why they vanished. Was it deliberate suppression, as some alternative historians suggest? The burning of the Library of Alexandria erased countless texts, and conquering cultures often dismantled the knowledge of those they defeated. Or did these techniques simply fade when the civilizations that mastered them collapsed, leaving only whispers in folklore? The irony is palpable. Today, we're using lasers and 3D printers to achieve what ancients might have done with methods we've yet to fully comprehend. The deeper we dig, the clearer it becomes our ancestors weren't primitive. They were innovators working with principles we're only beginning to uncover. Whether through sound, chemistry, or something entirely unexpected, their legacy challenges us to rethink not just history, but the very limits of human ingenuity. And that's a mystery worth pursuing. At the ruins of Tiwanaku, near the shores of Lake Titicaca, a network of intricate channels and reservoirs weaves through the stone like veins, proof that water wasn't just a resource for this ancient civilization, but a tool. The precision-cut basins and sluices aren't mere decorations. They're evidence of hydraulic engineering on a scale that rivals modern systems. But here's the puzzle. Why would a culture capable of moving 100-ton stones devote so much effort to controlling water? Unless, of course, water played a far more active role in their construction than we've assumed. One striking clue comes from the andesite blocks scattered across the site. Their surfaces often show unusual smoothness, as if the stone had been softened before shaping. Local legends speak of a liquid that could make rock pliable, and modern experiments reveal a startling possibility. When certain high-altitude plants, like those native to the Andes, are fermented, they produce organic acids capable of mildly dissolving silica in stone. Applied carefully, this could create a temporary, moldable state, allowing builders to carve or adjust blocks with astonishing precision before the rock rehardened. It's a fringe theory, but when you examine the seamless joints of Tiwanaku's walls, the idea doesn't seem so far-fetched. Then there's the role of water in transportation. The massive sandstone blocks at Ollantaytambo were quarried miles away across rugged terrain. Conventional theories suggest log rollers, but the logistics strain credibility. However, recent geological studies reveal ancient flood channels near the site, paths where seasonal water flows could have been harnessed to float or slide stones on barges or lubricated ramps. The Inca, like many megalithic cultures, were masters of turning nature's forces into allies, but the most tantalizing possibility lies in resonance. Water is a conductor of sound, and certain frequencies can create standing waves that reduce friction. At sites like the Pyramid of the Sun in Mexico, acoustical studies show unusual reverberation effects in underground water channels. Could ancient engineers have used these properties to tune their construction methods, making stones easier to move or shape? The evidence is circumstantial, but the patterns are undeniable. From the submerged megaliths of Yonaguni in Japan to the flood-aligned monoliths of Nabta Playa, water wasn't just present, it was part of the blueprint. The deeper we look, the clearer it becomes. These builders weren't just stacking stones, they were choreographing elements, bending physics to their will with a fluency we're only beginning to decode. And if water was their secret, it's a reminder that the past's greatest innovations might not lie in high-tech gadgets, but in the quiet mastery of nature's simplest forces. Step inside Newgrange, Ireland's 5,000-year-old passage tomb and clap your hands just once. The sound doesn't fade, it swirls, reverberating through the stone chamber like a ghostly echo. This isn't an accident. Across the globe, from the subterranean temples of Malta to the towering corridors of Chavín de Huanta in Peru, ancient builders crafted spaces where sound behaves in ways that defy simple explanation. Walls angled to amplify whispers, passageways tuned to specific frequencies, even stones that sing when struck. The question isn't whether these acoustic effects exist, but why they were so meticulously engineered. Modern researchers armed with sensitive microphones and frequency analyzers have mapped these phenomena in startling detail. At the hypogeum of Hal Saflieni, a labyrinthine underground complex on Malta, certain chambers resonate at precisely 110 Hz, a frequency known to alter brain activity, inducing trance-like states in listeners. In Peru, the Chavin cult used conch shell trumpets called pututus to blast low-frequency tones through their temple's ducts, creating a disorienting roar that worshippers described as the voices of gods. Were these sonic landscapes mere theatrical backdrops, or did ancient cultures understand something profound about the marriage of vibration and consciousness? The construction implications are even more tantalizing. Experiments by materials scientists show that resonant frequencies can reduce friction and even temporarily soften stone, a principle that might explain how massive blocks were maneuvered with such precision. Tibetan monks still chant at specific pitches when constructing sand mandalas, claiming the vibrations help align particles. Could similar techniques have been used to guide megaliths into place? At Gerbeckly, Teep, pillars adorned with acoustic symbols stand in circles that amplify certain harmonics, hinting at a ritual or practical application of sound. Then there's the enigma of the ringing rocks. Sites like Pennsylvania's Ringing Rocks Park or England's Carn Menin feature boulders that produce metallic tones when struck. Intriguingly, many of these rocks were quarried and incorporated into ancient monuments. The Stonehenge bluestones, for instance, originate from a Welsh outcrop known for its sonorous properties. Coincidence or evidence that builders selected materials not just for durability, but for their vibrational signatures, the most compelling theory bridges spirituality and physics. If, as some researchers suggest, sound waves can influence matter at a molecular level, then these sites might have been designed as harmonic engines, transforming ritual chants or drumbeats into tangible forces. Picture a priest's chant resonating through a chamber tuned like a giant tuning fork, its vibrations subtly altering the space's energy. It sounds mystical until you consider modern ultrasound technology, where focused sound waves can levitate objects or perform non-invasive surgery. Whether as tools for healing, portals for communion with the divine, or literal keys to moving mountains, the acoustics of these sites suggest a forgotten science, one where architecture wasn't just seen but heard. And as we decode their frequencies, we might not just uncover lost techniques, but rediscover an entire language of vibration written in stone. The idea that extraterrestrial visitors might have guided ancient builders isn't new, but it's far from simple fantasy. Look at the precision of the Great Pyramid's alignment to true north, or the way Puma Punku stones fit together with machined perfection. These feats seem to defy the technological limits of their time, sparking debates that stretch from academic journals to late-night conspiracy forums. But before dismissing the ancient astronaut theory outright, consider the anomalies that even mainstream science struggles to explain. Take the Dogon people of Mali, who for centuries described the star Sirius in ways that align with modern astronomy, including its invisible companion star, Sirius B, which wasn't discovered by telescopes until the 19th century. How could a tribe without written language or optical instruments know details invisible to the naked eye? Or examine the Nazca lines in Peru, massive geoglyphs so vast they're only recognizable from the air. Were they meant to signal beings above, or is their aerial perspective just a coincidence? Skeptics argue that humans are perfectly capable of ingenuity without alien intervention. The Antikythera mechanism, a 2,000-year-old Greek device for predicting astronomical events, proves ancient civilizations had sophisticated mechanical knowledge. And the pyramid's alignment could have been achieved using simple tools like the Merkit, an ancient Egyptian shadow clock, but even these explanations leave gaps. Why do so many megalithic sites share uncanny geometric similarities across continents, as if following a universal template? The pyramids of Giza, Teotihuacan, and Xi'an in China all mirror the Orion constellation's belt, a pattern too precise to ignore. Then there's the enigma of impossible materials. The sarcophagus in the Great Pyramid's King's Chamber is made of granite so hard it would require diamond-tipped tools to replicate today. Yet there's no evidence the Egyptians possessed such technology. Similarly, the vitrified stone walls of Sacsayhuaman show signs of extreme heat, as if melted by some advanced process. Could these be traces of tools or techniques beyond our current understanding? The most compelling arguments for extraterrestrial influence often hinge on mythology. Cultures worldwide, from Sumer to the Maya, describe sky gods who descended with knowledge of agriculture, astronomy, and architecture. The Sumerian Anunnaki, the Vedic Vimanas, even the biblical Ezekiel's wheel, these stories share eerie parallels with modern UFO accounts. Are they merely imaginative myths or fragmented memories of actual encounters? Science demands evidence, and here's where the theory stumbles. No physical proof of alien technology has been found at megalithic sites. No spacecraft parts, no alien artifacts, just unanswered questions. But perhaps the real value of these ideas isn't in proving aliens visited Earth. It's in challenging us to rethink human potential. If our ancestors achieved the impossible with nothing but stone and sweat, what does that say about the untapped capabilities hidden in our own past and future? The stones remain silent, but their mysteries urge us to keep looking, both outward to the stars and inward to the ingenuity we've yet to fully reclaim. Etched into the weathered surface of a standing stone in Scotland's Callanish complex, a spiral swirls like a frozen whirlpool, a design echoed on temple walls in Malta, carved into Mesoamerican stelae and scratched onto cave ceilings in Australia. These aren't random doodles, they're deliberate symbols, a visual language spanning continents and epochs. But what were they trying to say? The answer might lie in the stars. At Newgrange, Ireland's 5,000-year-old tomb, the same triple spiral motif appears at the exact spot where winter solstice sunlight strikes the inner chamber. Coincidence, or a celestial marker, a way of saying, this is where the sun reborns itself? The repetition of these symbols across disconnected cultures is staggering. Take the zigzag pattern found on Mesopotamian clay tablets, Inca textiles, and the monoliths of Gerbeckly Teep. Hydrologists note its uncanny resemblance to waveforms, leading some to theorize it represents water's primal power. Others see it as a symbol of the serpent, a near-universal emblem of wisdom and rebirth. Then there's the concentric circle, carved into stones from Brittany to Bolivia. Archaeoastronomers suggest these might depict planetary orbits or eclipses, while anthropologists link them to shamanic visions of the cosmos, the truth. These symbols likely served multiple layers of meaning: practical, spiritual, and astronomical, all woven together like threads in a grand tapestry. Some of the most enigmatic symbols defy easy interpretation. The handbag motif, a T-shape with a rounded base, appears in Sumerian reliefs, Olmec carvings, and even Maori petroglyphs. Mainstream archaeology labels it a stylized container, perhaps holding sacred grains or incense. But alternative researchers point to its resemblance to ancient energy devices described in Vedic texts. Could it represent a shared technological memory, or is it a metaphor for carrying knowledge between worlds? the mystery deepens when you notice its presence at sites like Gerbeckly Teep, where it's positioned near carvings of headless humans and strange beasts as if part of a larger, lost narrative. Then there are the geometric grids found at sites like Noth in Ireland or Chavin de Huanta in Peru. At first glance, they resemble game boards, but when overlaid with star charts, some align with constellations like Orion or the Pleiades. The Maya took this further, encoding entire calendars into their temple facades. At Capon, a flight of steps is inscribed with hieroglyphs that track Venus's cycles with pinpoint accuracy. These weren't just decorations, they were functional archives, stone textbooks preserving celestial math for future generations. The most haunting symbols are those that seem to tell stories. On the walls of the Hypogeum in Malta, red ochre paintings depict stick figures with elongated heads echoing the Star People, described in Dogon legends and Aboriginal Dreamtime tales. At the Temple of the Feathered Serpent in Teotihuacan, carvings show deities emerging from spirals, as if stepping through portals. Indigenous elders from multiple traditions insist these aren't myths but histories, records of a time when humans communicated with other realms. Decoding these symbols is like piecing together a planetary jigsaw puzzle where half the pieces are missing. But one thing is clear, our ancestors weren't just building structures. They were embedding messages about the cosmos, about their gods, about the nature of existence itself. Whether as star maps, sacred formulae, or warnings for the future, these carvings challenge us to listen not just with our eyes but with our intuition. The stones are speaking. The question is, do we understand the language? High in the Andes, the Inca city of Machu Picchu clings to a mountain ridge, its stone walls standing unshaken through centuries of earthquakes, while modern buildings nearby crumble. The secret lies in the masonry, blocks cut with such precision that they lock together without mortar, shifting and settling during tremors like pieces of a dynamic puzzle. This wasn't just craftsmanship, it was engineering genius. The Incas didn't fight nature's forces, they danced with them. Take a closer look at those walls. The stones aren't uniform rectangles but irregular polygons, each face uniquely angled to interlock with its neighbors. This, a jigsaw design seen at sites like Sacsayhuaman and Ollantaytambo, isn't just for show. When seismic waves hit, the blocks dissipate energy by moving slightly, then settling back into place, a principle modern engineers call dynamic friction. Compare that to rigid, mortar-bound walls which crack under stress. The Inca approach was so effective that Spanish colonists, baffled by its resilience, often built their churches directly atop Inca foundations, trusting indigenous stonework over their own techniques. But how did they achieve such precision without metal tools or written plans? The answer might lie in a meticulous process called sighting and trial fitting. Imagine a mason shaping a granite block, then hauling it into position to check the fit. Too tight, they'd chip away a few millimeters. Too loose, adjust the angle. Repeat for months or years until the fit was perfect. At unfinished sites like Cachicota, you can see these in-progress blocks, their surfaces pocked with small divots where adjustments were made. It's a testament to patience but also to something deeper, an intimate understanding of stone's behavior. The Incas didn't just work on stone, they worked with it. They selected different rock types for specific purposes: andesite for its durability, limestone for easier carving, and positioned stones according to their natural grain, reducing the risk of fractures. Some researchers believe they even used sound to test quality, tapping blocks to listen for hidden flaws, much like modern engineers use ultrasonic testing. Then there's the matter of logistics. Moving 100-ton stones up steep mountainsides would be a challenge even today. the Incas likely used a combination of log rollers, ramps, and manpower, but recent discoveries hint at cleverer methods. Near Ollantaytambo, archaeologists found polished cobblestone roads with grooves that match the bases of monoliths, suggesting the stones were slid along lubricated tracks, possibly with water or clay reducing friction. Other theories propose the use of counterweight systems, where smaller stones acted as balances to pivot larger ones into place, the most humbling realization. This knowledge wasn't confined to a few master builders. It was systemic, passed down through generations in a culture that revered engineering as both science and art. When the Spanish arrived, they documented Inca architects using knotted strings quipus to calculate dimensions and angles, proof that their primitive techniques were backed by sophisticated mathematics. Today, as seismologists study Inca walls to improve earthquake-resistant designs, the legacy is clear. These builders didn't just construct monuments. They crafted conversations with the earth itself, listening to its movements and answering with stone. And in their silent, steadfast walls, they left a challenge to rebuild not just our structures, but our relationship with the forces that shape them. Beneath the sands of Egypt, far from the iconic pyramids, lies a hidden world of megalithic mysteries that challenge our understanding of ancient engineering. Deep within the Serapeum of Sakara, massive granite sarcophagi, each weighing up to 70 tons, stand as silent witnesses to a lost technology. Their surfaces are polished to a mirror finish, their corners sharp enough to slice paper, and their interiors hollowed out with geometric precision that would require diamond-tipped tools today. Yet these boxes date back over 3,000 years, to an era when Egypt's tools were supposedly limited to copper chisels and stone hammers. How did they achieve such perfection? The enigma deepens when you examine the material itself. Many of these boxes are carved from diorite, a volcanic rock so hard it ranks just below diamond on the Mohs scale. Modern masons would struggle to shape it without industrial-grade equipment, yet ancient artisans not only cut it, they drilled perfect cylindrical holes into it. Archaeologists have uncovered diorite cores from Egyptian sites, their spiral grooves so uniform they suggest the use of advanced rotary tools. The implications are staggering. Either the Egyptians possessed machining technology far beyond what we've credited them with, or they mastered a forgotten method of working stone that defies conventional physics. Compare these feats to similar megaliths worldwide. In South America, the Inca shaped andesite with comparable precision, while in India, the Kailasa temple was carved from a single basalt cliff with intricate detail. The parallels are uncanny. Were these cultures sharing knowledge across continents, or did they independently stumble upon the same advanced techniques? One clue might lie in the tool marks. At Abu Rawash, another Egyptian site, archaeologists found granite blocks with cuts so clean they resemble those made by modern wire saws. Nearby, hieroglyphs depict what some interpret as tubular drills, tools that, if real, would rewrite the timeline of technological progress. Then there's the labyrinth beneath the Giza Plateau, a network of tunnels and chambers described by Herodotus as a wonder beyond the pyramids. Modern expeditions have mapped only a fraction of this subterranean complex, but what they've found is baffling. Walls lined with megalithic blocks fitted together like puzzle pieces, some emitting faint electromagnetic anomalies. Similar underground systems exist in Turkey's Derinkuyu and Malta's Hypogeum, suggesting a global pattern of subterranean engineering. Were these spaces ceremonial, practical, or something more profound? The most provocative evidence comes from experimental archaeology. When researchers attempted to replicate Egypt's stonework using copper tools and sand abrasives, they found the process agonizingly slow, far too sluggish to explain the scale of surviving monuments. But when they tested alternative methods like vibration-assisted cutting or chemical softening agents, the results were startlingly close to ancient precision. This raises a tantalizing possibility that the primitive tools we've attributed to these builders might be red herrings, masking a sophisticated understanding of material science we're only beginning to grasp. From the diorite drills of Sakara to the echoing chambers beneath Giza, Egypt's megalithic legacy isn't just about what was built, but how. Each perfectly cut stone is a question etched in rock, inviting us to reconsider not just the limits of ancient technology, but the very narrative of human innovation. And as we piece together these fragments, one truth becomes clear: the past holds secrets we've only begun to uncover. Buried beneath a windswept hill in southeastern Turkey, Gerbeckly Teep rises from the earth like a forgotten cathedral, a sprawling complex of massive T-shaped pillars, some weighing over 16 tons, arranged in precise circles. What makes this site truly astonishing isn't just its scale, but its age. Carbon dating places its construction at around 9,600 BCE, a staggering 6,000 years before Stonehenge and 5 millennia before the first cities of Mesopotamia. This wasn't the work of a settled agricultural society. It was built by hunter-gatherers, people who supposedly lacked the organization or technology to quarry, transport, and erect such monuments. So why did they do it, and why, centuries later, was it deliberately buried under thousands of tons of earth, as if someone wanted to erase it from memory? The pillars themselves are a gallery of mysteries, carved with elaborate reliefs of foxes, scorpions, and vultures. These aren't mere decorations. The animals twist and coil around the stone, their positions too deliberate to be random. Some researchers believe they're part of a symbolic language, a way to encode myths or star maps. Others point to the vultures, a clue, perhaps, to funerary rites involving sky burial, where the dead were left to be cleansed by birds. But the most haunting detail is the humanoid arms carved along the sides of the pillars, bent at the elbows as if frozen in motion. Are they guardians? Ancestors or representations of beings we've yet to understand? Then there's the architecture. The circular enclosures, each centered by two towering pillars, echo later megalithic sites like Stonehenge, yet Gerbeckly Teep predates them all. Even more puzzling, there's no evidence of permanent dwellings nearby. This wasn't a village or city. It was something else, a ritual space, a pilgrimage site, or maybe an observatory. The alignment of the pillars suggests they might have tracked celestial events, like the rising of Sirius or the movement of the Pleiades. If so, it means these hunter-gatherers possessed an astronomical sophistication we never imagined. The site's burial is another enigma. Around 8,000 BCE, someone methodically filled the entire complex with rubble, preserving it like a time capsule. Was this an act of reverence, hiding sacred ground from invaders or the ravages of time? Or was it suppression, an attempt to erase a belief system that had fallen out of favor? The answer might lie in the transition happening at the time, the dawn of agriculture. Gerbeckly Teep's builders lived on the cusp of this revolution, and some theorists propose the site was a gathering place for nomadic groups to exchange knowledge, including early farming techniques. Once that knowledge spread, perhaps the site's purpose faded, and it was consigned to the earth, but the implications run deeper. If hunter-gatherers could build Gerbeckly Teep, what else were they capable of? The standard narrative says civilization began with farming, which allowed surplus resources and specialization. Yet here's proof that complex society might have emerged the other way around, that ritual and communal labor came first, driving the need for agriculture to sustain large-scale projects. It's a paradigm shift. Gerbeckly Teep doesn't just rewrite history, it forces us to reconsider what it means to be civilized today, only a fraction of the site has been excavated. What remains hidden could hold even greater revelations. With each layer of soil removed, we're not just uncovering stones, we're peeling back the layers of human ambition, ingenuity, and perhaps even our oldest fears and dreams. The pillars of Gerbeckly Teep stand as silent sentinels, guarding secrets that could redefine our very origins, and the most humbling thought, they've been waiting for us to find them for 12,000 years. Standing atop the rolling hills of Glastonbury Tor in England, you can almost feel the land vibrate beneath your feet, not with earthquakes, but with something subtler, like a whisper of energy humming through the earth itself. This sensation isn't just imagination. For centuries, people have reported strange phenomena at sacred sites: compass needles spinning wildly, electronic devices malfunctioning, even unexplained surges of warmth or tingling in the body. What if these experiences hint at something far older and more deliberate? A growing number of researchers believe megalithic sites weren't just placed randomly. They were strategically positioned along invisible pathways known as ley lines, forming a vast, interconnected energy grid that once pulsed across the planet. The concept isn't as far-fetched as it sounds. Modern science confirms that Earth is crisscrossed by natural electromagnetic currents, generated by the planet's rotation, mineral deposits, and even underground water flows. Instruments at places like Avebury in England or the Great Pyramid in Egypt detect measurable spikes in these fields, often aligning with the solstices or lunar cycles. Even more intriguing, many megalithic sites sit atop geological faults or aquifers, places where subterranean water movement could generate piezoelectric effects, converting mechanical stress into electrical charge. The quartz-rich granite used in countless ancient structures amplifies this possibility. Quartz is known to conduct and store energy, a principle exploited in modern electronics. Were these builders intentionally tapping into Earth's natural circuitry? Then there's the ley line mystery, first mapped by early 20th century antiquarians. These straight alignments connect ancient sites across staggering distances. The St. Michael Line in England, for example, runs from Cornwall to Norfolk, threading through stone circles, hilltop shrines, and medieval churches built atop older sacred ground. Similar alignments appear in Peru, where the Sec system of Cusco radiates from the Coricancha temple like spokes on a wheel, linking Huaca's sacred spots in precise geometric patterns. Skeptics dismiss ley lines as coincidence, but the mathematical odds of so many sites falling on straight paths are slim. Could these lines mark channels of energy, like acupuncture meridians for the planet? The most compelling evidence comes from modern experiments. Researchers using magnetometers at Carnac in France, home to thousands of standing stones, found abnormal fluctuations along the megalithic rows, as if the stones were acting as conduits. In Bolivia, the ruins of Tiwanaku show traces of powdered magnetite in their mortar, a mineral known to interact with magnetic fields. And at Delphi, the ancient Greeks built their oracle's temple directly over a geological fissure emitting ethylene gas, which induces trance states. These findings suggest a sophisticated understanding of geophysical phenomena, harnessed for purposes we're only beginning to grasp. But what was the grid's function? Some theorize it stabilized tectonic plates or enhanced crop growth through subtle energy. Others propose it was a global communication network, with megaliths acting like resonant antennas. The most provocative idea comes from traditions like the Aboriginal songlines, where certain pathways are said to carry dreaming energy that can be accessed through ritual or sound. If true, these sites might not just mark energy, they could amplify, focus, or even transmit it. The implications are profound. If ancient cultures perceived and manipulated Earth's energies, their world, wasn't just spiritual, it was deeply scientific. blending observation of nature with intuitive knowledge we've since forgotten. As we remap these ley lines with satellites and quantum sensors, we're not just rediscovering lost technology, we're relearning a language of the land written in stone and whispered through the earth itself. And perhaps in doing so, we're reactivating a connection our ancestors knew well, one where human and planet were never separate, but parts of a living, breathing circuit. In the quiet town of Homestead, Florida, a bizarre monument rises from the earth, a sprawling complex of coral rock sculptures weighing up to 30 tons each, all shaped and positioned by one man with no formal training or heavy machinery. Edward Leedskalnin, a 5-foot-tall, 100-pound Latvian immigrant, spent 28 years building what's now called Coral Castle, claiming he'd unlocked the secrets of the pyramids. Working alone under cover of darkness, he quarried, carved, and lifted blocks heavier than those in the Great Pyramid using nothing but handmade tools and a system of chains and tripods. When asked how he managed it, he'd simply smile and say he understood the laws of weight and leverage, but the truth might be stranger than his humble explanations. Leedskalnin left behind cryptic clues in his writings, hinting at a fascination with magnetism and perpetual motion holders, devices he claimed could manipulate gravitational forces. Some believe he harnessed Earth's natural magnetic fields, aligning his coral blocks along unseen energy lines. Witnesses reported seeing him place ordinary-looking metal boxes near the stones, after which they'd seemingly move on their own. Skeptics dismiss these accounts as tall tales, but modern experiments reveal a tantalizing possibility. Coral rock contains high concentrations of magnetite, a mineral sensitive to electromagnetic fields. If Leedskalnin discovered a way to temporarily neutralize or redirect gravity's pull using precise magnetic frequencies, it would explain how one man could achieve the impossible. The parallels to ancient megalithic sites are uncanny. Like the Inca stonemasons, Leedskalnin worked without blueprints, shaping each block to fit its neighbor perfectly. His famed 9-ton gate, a massive coral slab balanced so precisely it could be pushed open with a finger, mirrors the frictionless precision of Egyptian temple doors. Even his choice of material echoes antiquity coral, like limestone, is porous and relatively soft when first quarried but hardens over time, a property ancient builders may have exploited to shape stones before they fully cured. But the most haunting question isn't how he built Coral Castle, it's why. Leedskalnin claimed it was a tribute to a lost love, yet the site's layout suggests something deeper. An obelisk points to the North Star, while a crescent moon-shaped pool aligns with solstices. His Florida Stonehenge, as some call it, even includes a working sundial and a telescope-like tube aimed at the celestial pole. Was this a lonely man's obsession or a modern attempt to replicate forgotten astronomical knowledge? Leedskalnin took his secrets to the grave, leaving behind only a riddle. I have discovered the secrets of the pyramids. I have found out how the Egyptians and the ancient builders in Peru, Yucatan, and Asia, with only primitive tools, raised and set in place blocks of stone weighing many tons. Whether through magnetism, sound, or some other lost principle, his work stands as a bridge between ancient wonders and modern mysteries, proof that the line between legend and science is thinner than we think. The Great Pyramid of Giza doesn't just tower over the desert, it whispers equations in stone. Measure its perimeter, divide by twice its height, and you'll get a number startlingly close to pi, 3.14. This isn't just a neat coincidence. The pyramid's dimensions encode mathematical relationships with a precision that would make a modern engineer pause. How could builders 4,500 years ago embed a constant we didn't formally define until the ancient Greeks? And the pyramid isn't alone. From Stonehenge's Pythagorean triples to Angkor Wat's celestial geometry, these structures hum with numerical secrets that defy their supposed eras. Take Stonehenge's Sarsen circle. The spacing between its uprights forms right-angled triangles that match Pythagorean ratios millennia before Pythagoras was born. The outer ring's diameter, 116.6 feet, mirrors the inner bluestone circle's proportions in a perfect 1:10 ratio. Were these measurements accidental or proof of a mathematical tradition passed down through generations? The same patterns emerge in Mexico's Teotihuacan, where the pyramid of the sun's base perimeter equals the circumference of a circle with its height as the radius, another silent nod to pi. The precision goes deeper than simple ratios. At the Temple of Karnak in Egypt, the hypostyle hall's columns are spaced according to harmonic intervals, creating acoustic resonances that amplify specific frequencies. In Cambodia, the corridors of Angkor Wat align with the solar year's length down to the minute, its bas-reliefs depicting celestial events with astronomical accuracy. These aren't just artistic choices, they're calculations etched in stone. But here's the puzzle. If these cultures possessed such advanced math, why no surviving textbooks or equations? Perhaps the answer lies in oral traditions or lost artifacts. The ancient Egyptians, for instance, used rope stretchers, surveyors who knotted cords at precise intervals to measure land. Could these have doubled as computational tools? Similarly, the Maya's Vigesimal system, based on 20 instead of 10, allowed complex astronomical calculations without symbolic notation. Their knowledge wasn't written in textbooks but woven into architecture, a living library of stone. The most tantalizing theory suggests a shared cosmological language. The golden ratio, found in nature's spirals and galaxies, appears in the Parthenon's facade and the Great Pyramid's chambers. The Fibonacci sequence, seen in sunflower seeds and hurricanes, structures the layout of sites like Giza and Machu Picchu. Were these cultures independently discovering universal constants, or did they inherit fragments of a lost system? The stones don't just stand, they count, measure, and compute. Whether by intention or intuition, their builders tapped into a numerical harmony that still echoes across millennia. And that raises a humbling thought. If we've only just begun decoding their math, what other secrets might they have left for us to find? From the moment the first light of dawn creeps through Newgrange's narrow entrance to illuminate its inner chamber on the winter solstice, it's clear these ancient builders weren't just stacking stones, they were mapping the sky. This 5,000-year-old Irish tomb isn't an outlier. Across the globe, from the stepped pyramids of Chichen Itza to the sprawling stone circles of Nabta Playa, megalithic cultures wove celestial knowledge into the very fabric of their architecture with a precision that still leaves astronomers in awe. Take Chichen Itza's El Castillo Pyramid. During the spring and autumn equinoxes, the setting sun casts a shadow along its northern staircase, creating the illusion of a serpent slithering down to earth, a representation of Kukulkan, the feathered serpent deity. This isn't just symbolic theater, it's a meticulously engineered solar calendar tracking the year's turning points with uncanny accuracy, even more impressive. The pyramid's 4 stairways each have 91 steps, totaling 364 when combined with the shared platform at the top, mirroring the solar year's length. The Maya didn't just observe the cosmos, they encoded its rhythms into stone. Then there's the lesser-known but equally extraordinary site of Nabta Playa in the Egyptian desert. Over 7,000 years ago, nomadic pastoralists arranged slabs of rock into circles and lines, aligning them to the summer solstice sunrise and the brightest stars in Orion's belt. These people lived millennia before the pharaohs, yet their understanding of celestial mechanics rivaled later civilizations. The stones even hint at an early grasp of precession, the slow wobble of Earth's axis that shifts star positions over millennia. How did a culture without written language or permanent settlements achieve this? The answer might lie in necessity. For agricultural societies, tracking solstices and equinoxes meant predicting planting and harvest cycles. But many of these sites go far beyond practical needs. At Mnajdra in Malta, a temple corridor aligns with the equinox sunrise so precisely that sunlight slices through like a laser, illuminating carvings of spiral motifs linked to rebirth. In Peru, the 13 towers of Chanquillo form a prehistoric solar observatory, where the sun's movement between the towers mark dates with near calendrical precision. These weren't just tools, they were sacred interfaces between earth and sky. The deeper mystery is how disparate cultures separated by oceans and millennia arrived at such similar solutions. Did they share knowledge through lost trade routes, or is there something universal about how humans perceive celestial patterns? The Dogon people of Mali, for instance, knew about Sirius B, a star invisible to the naked eye, centuries before telescopes confirmed its existence. Their legends say this knowledge came from amphibious beings called Namo. While mainstream science dismisses this as myth, it underscores a tantalizing question: how much of ancient astronomy was taught, and how much was rediscovered independently? Perhaps the most profound revelation lies in what these alignments suggest about ancient worldviews. To them, the heavens weren't distant and detached. They were a living, breathing part of daily existence. When the builders of Stonehenge positioned their blue stones to frame the summer solstice sunrise, or when the architects of Angkor Wat designed their temple to mirror the Draco constellation, they weren't just marking time, they were forging a bond between the terrestrial and the celestial. In their eyes, the stones didn't just point to the stars, they spoke with them. Recent scientific surveys have uncovered something startling. Many of the world's most enigmatic megalithic sites sit directly atop pockets of unusual geomagnetic activity. At Carnac in France, where thousands of standing stones stretch for miles like a petrified army, instruments detect erratic fluctuations in the local magnetic field, with some monoliths registering higher readings than the surrounding Earth. Similar anomalies appear at Avebury's stone circles, the temples of Malta, and even the Moai statues of Easter Island. The odds of this being random are vanishingly slim. So why would ancient builders go to such extraordinary lengths to erect their monuments in these specific spots? The answer might lie in forces invisible to the naked eye, forces our ancestors somehow sensed and harnessed. Modern geologists know Earth's crust is laced with natural electromagnetic currents, generated by everything from underground water, flows to concentrations of magnetic minerals like magnetite. These energy pathways, often called ley lines or dragon lines in folklore, can produce measurable effects, from compass needles spinning erratically to sudden temperature shifts. At the Rollright Stones in England, visitors report strange sensations when standing near certain rocks, and scientific instruments confirm localized spikes in magnetic intensity. Even more intriguing, many of these sites align with geological faults or underground aquifers, where moving water amplifies these subtle energies through the piezoelectric effect, the same principle behind modern quartz watches. Were these locations chosen not just for their visibility or elevation, but for their unseen power? The implications deepen when examining how these sites were constructed. The massive basalt columns of Ireland's Giant's Causeway and Scotland's Callanish stones contain high concentrations of quartz, a mineral known to amplify electromagnetic energy. Experiments show that when quartz-rich stones are subjected to pressure or vibration, they generate small electrical charges. Now, imagine an entire circle or pyramid built from such material. strategically placed where Earth's magnetic field is most active. Could these structures have functioned as primitive energy conduits or resonators? Oral traditions hint at this possibility. Welsh legends speak of the singing stones of Preseli, where the blue stones of Stonehenge were quarried, vibrating with otherworldly tones when struck. Indigenous Australian elders describe sacred rocks that hum during ceremonies, aligning with their songline's ancient path said to carry spiritual energy. Even the shapes of these monuments suggest an awareness of energy dynamics. The conical mounds of Newgrange and Noath, the pyramidal geometries of Giza and Teotihuacan, all are forms known to focus electromagnetic waves. Modern studies of pyramid structures reveal they can concentrate energy in their inner chambers, a phenomenon some researchers believe was deliberately engineered. At Bosnia's controversial Pyramid of the Sun, scans detected an unexplained beam of energy emanating from its apex. While mainstream archaeology remains skeptical, the data raises provocative questions. Did ancient cultures perceive these forces intuitively, or did they possess instruments now lost to measure and manipulate them? The most compelling evidence comes from modern attempts to replicate these effects. In Japan, researchers found that certain stone arrangements, like those at Nabta Playa, can generate weak but detectable electromagnetic fields when exposed to sunlight. In Peru, engineers experimenting with Andean granite discovered that specific frequencies of sound cause the stone to vibrate in ways that temporarily alter its magnetic properties. These findings blur the line between myth and science. Could the legends of stones levitating into place describe a real, if poorly understood, phenomenon? Whether as sacred batteries, cosmic antennas, or something beyond our current grasp, these sites challenge the notion that ancient builders were merely stacking rocks. They were interfacing with the planet itself, tapping into a living grid of energy we're only beginning to map. And as we measure their magnetic whispers with modern tools, we might be rediscovering a forgotten language, one written not in words but in stone and force. The idea that ancient builders might have crafted their megalithic masterpieces not by carving solid rock, but by pouring a form of stone concrete, sounds like something from a science fiction novel. Yet mounting evidence suggests this theory might hold weight. Take the towering blocks of the Great Pyramid, where microscopes reveal air bubbles trapped in the stone, a telltale sign of poured material rather than quarried bedrock. Or examine the temple walls of Sacsayhuaman, where the stones seem to fuse together seamlessly, as if melted into place. Could these builders have mastered a lost art of geopolymer chemistry, turning loose stone powder into liquid rock? The Geopolymer Hypothesis, first proposed by materials scientist Joseph Davidovits, argues that many ancient stones were actually reconstituted limestone. The process would have been surprisingly simple. Crush local limestone into powder, mix it with alkaline solutions derived from plant ash or natron, a naturally occurring salt, and pour the slurry into wooden molds. As the mixture cured, it would harden into a synthetic stone nearly indistinguishable from the real thing. Chemical analyses support this. Samples from Egyptian pyramids show trace elements like opal and magnesium alumina, markers of man-made stone. Even more compelling, hieroglyphs describe a substance called poured stone, and some pyramid blocks contain organic fibers, likely from the molds used to shape them. But the implications go far beyond Egypt. In Peru, researchers found vitrified surfaces on andesite stones at Ollantaytambo, as if exposed to extreme heat or chemical treatment. Local legends speak of a plant-based liquid that could soften rock, and experiments confirm certain organic compounds can temporarily weaken stone's crystalline structure. Similarly, the Roman Pantheon's dome, still the world's largest unreinforced concrete structure, uses a recipe with volcanic ash that self-heals cracks, a technology we've only recently reinvented. Critics argue that quarry marks and tool grooves prove most megaliths were carved, not cast. Yet even here, anomalies persist. At Baalbek, the so-called Stone of the Pregnant Woman shows tool marks on its sides but an eerily smooth underside, as if one face was molded. And at Coral Castle in Florida, Edward Leedskalnin claimed to have rediscovered the ancients' stone casting secrets, though he never revealed his methods. The truth might lie in a hybrid approach where builders combined carving and casting, using geopolymers to perfect joints or repair flaws. If proven, this theory wouldn't just rewrite history, it would revolutionize our understanding of ancient innovation. These builders weren't primitive laborers, they were material scientists manipulating chemistry on a scale we're only beginning to comprehend. Their stones don't just stand as monuments, but as silent challenges to our assumptions. And the most humbling thought, we might still be catching up to their brilliance. Buried beneath the rolling green hills of Ireland's Boyne Valley, Newgrange's massive passage tomb waits in darkness until the winter solstice dawn, when a single shaft of sunlight pierces its narrow entrance, crawling inch by inch to illuminate the inner chamber. This isn't just a feat of engineering, it's a bridge between worlds, across oceans and eras, from Egypt's mastabas to China's underground palaces. Ancient cultures shaped stone into thresholds for the dead, crafting monuments that didn't just house bodies but guided souls. The eerie similarities in their designs suggest something profound, a shared vision of architecture as a cosmic roadmap, etched in earth and aligned with the stars. Take the mastabas of early Egypt, flat-roofed, rectangular tombs with shafts descending into burial chambers. At first glance, they seem worlds apart from Newgrange's spiraling passage. Yet both share a core principle: the dead weren't meant to stay buried. The mastaba's false door, a carved portal that couldn't physically open, was believed to allow the ka, a person's life force, to pass between realms. Similarly, Newgrange's solstice light show wasn't spectacle. It was sustenance, symbolizing rebirth for those interred within. Even the materials whisper of transcendence. The white quartz facade of Newgrange, glittering like starlight, mirrors the T-shaped pillars of Gerbeckly Teep, another site where stone seems to pulse with celestial intent. Venture east to China's Han Dynasty tombs, and the pattern deepens. Here, jade suits clad emperors to preserve their bodies for eternity, while underground chambers mirror celestial maps, their ceilings inlaid with pearls and gems to replicate the night sky. Like the pyramids of Giza, these tombs align with the northern polar stars, the immovable axis around which ancient cultures believed the heavens turned. In Mesoamerica, the Maya built pyramid tombs like Palenque's Temple of the Inscriptions, where King Pakal's sarcophagus lies beneath a labyrinth of stairways, his body adorned with jade to speed his journey to the underworld. Parallels are uncanny. Whether in Ireland or Guatemala, builders oriented death toward rebirth, embedding tombs with cosmic cues to navigate the afterlife. But why this global obsession with stone and stars? One answer lies in the earth itself. Many tombs sit atop geological faults or underground water sources, zones where natural electromagnetic activity is highest. Modern sensors at sites like the hypogeum of Hal Saflieni in Malta detect resonant frequencies in burial chambers, frequencies known to induce trance states. Were these spaces designed as vibrational gateways, using sound and stone to alter consciousness and ease passage to the next life? The ancient Egyptians certainly thought so. Their pyramid texts inscribed on tomb walls describe the dead pharaoh ascending via sunbeams, his voice merging with the whirlwind of the stars. The most haunting tombs, though, are those that defy categorization. In Japan's coffin mounds, keyhole-shaped earthworks spanning miles, elite burials face east toward the rising sun, their forms echoing the same sacred geometry found in Babylonian ziggurats. In Peru, the Chachapoya mounted their dead in cliffside sarcophagi, their bodies curled like seeds awaiting spring. Each culture's approach was unique, yet all returned to a common truth: death wasn't an end, but a transformation. And the stones they left behind, not just monuments, but vessels, silent witnesses to humanity's oldest, most universal hope, that what lies beyond is not darkness, but light. In a quiet corner of Wales, a team of archaeologists and engineers gathers around a massive bluestone, their bronze tools and rawhide ropes laid out with hopeful precision. They're attempting what the builders of Stonehenge accomplished over 4,000 years ago, moving a multi-ton monolith across rugged terrain using only Neolithic technology. The result, after weeks of backbreaking labor, the stone has barely budged. This isn't an isolated failure. From Egypt to Peru, modern attempts to replicate ancient megalithic techniques often end in frustration, exposing just how much we've underestimated the ingenuity of our ancestors. Take the case of the Aswan obelisk experiment. In the 1990s, researchers tried to carve and transport a 25-ton granite block using copper chisels, wooden sledges, and teams of volunteers. Despite months of effort, they couldn't achieve the mirror-smooth surfaces or precise angles seen on actual obelisks. The team concluded that either their tools were inadequate or the ancients had access to methods we've yet to rediscover. Similar struggles plagued efforts at Ollantaytambo, where engineers using log rollers and ropes found it nearly impossible to maneuver the site's famous pink granite blocks up steep inclines, yet the Inca did it routinely. The gaps in understanding become even starker when examining stone shaping. At a site in Massachusetts, stonemasons attempted to recreate the precision of Peru's polygonal walls using only hammerstones and sand abrasives. While they managed rough fits, the flawless, mortarless joints of Sacsayhuaman remained out of reach. One participant noted, "It's not just skill, it's like they had a different relationship with the stone, as if it obeyed them." This sentiment echoes among experimental archaeologists, who often report an uncanny disconnect between textbook theories and hands-on reality. Perhaps the most humbling failures involve megalithic transportation. The famous Easter Island statue experiment, where teams tried to walk a replica moai using ropes and pivots, ended with the statue toppling into the dirt. Yet Polynesian oral histories insist their ancestors moved these giants easily, even describing the statues gliding into place. Similarly, attempts to float Stonehenge's bluestones on wooden rafts, a popular theory, revealed how easily the logs would have snapped under the weight. Why do these experiments fall short? Some blame missing context, oral traditions, or on-site tricks lost to time. Others propose that ancient builders used perishable tools or materials we haven't considered, like plant-based lubricants or vibration-assisted lifting. A few even speculate about forgotten physics principles, pointing to legends of stones softened by sound or herbs. Whatever the reason, each failed experiment shines a light on a deeper truth. These weren't primitive people stumbling toward progress. They were masters of their craft, wielding knowledge we're still straining to comprehend. The most telling detail, even with modern machinery, replicating some megalithic feats is daunting. When Japan rebuilt part of the Great Pyramid for a documentary using cranes and steel tools, the team admitted their version lacked the precision of the original. It's a sobering realization that 4 millennia later, with all our technology, we're still playing catch-up to the brilliance of the past, and that, perhaps, is the greatest mystery of all. Archaeology, at its core, is a science of stories piecing together narratives from fragments of the past. But what happens when new evidence threatens to rewrite those stories? The study of megalithic sites has long been a battleground between established timelines and discoveries that simply don't fit. Take the case of Gerbeckly Teep. When this 12,000-year-old complex was unearthed in Turkey, it shattered the conventional belief that hunter-gatherers lacked the organization to build monumental structures. Overnight, textbooks had to be revised, yet the discovery faced years of skepticism. Why? Because it upended a fundamental assumption that civilization began with agriculture. For many in the field, accepting Gerbeckly Teep meant admitting we'd gotten human history profoundly wrong. This resistance isn't just about stubbornness, it's about the inertia of academic paradigms. The scientific method thrives on skepticism, but when anomalies pile up, the line between healthy caution and institutional bias blurs. Consider the precision of Puma Punku's stonework. The andesite blocks, cut with near-machined accuracy, suggest tools or techniques beyond what's documented in the archaeological record. Yet proposing advanced ancient technology often invites accusations of pseudoscience. The irony: modern engineers still can't replicate these feats with period-appropriate tools. When independent researchers like Christopher Dunn suggest the Egyptians might have used sonic drills or geopolymers, their work is dismissed as fringe, despite physical evidence like the diorite cores from Sakara, which show drill marks matching advanced machining. The tension often boils down to methodology. Mainstream archaeology relies heavily on context. Artifacts must fit within known cultural frameworks. A bronze chisel found at a pyramid site. That's evidence. A theory about vibration-assisted stone cutting. That's speculation, unless you have a vibrating chisel in a museum. But what if the tools were perishable, like plant-based solvents or sound devices made of wood and sinew? Absence of evidence isn't evidence of absence, yet the burden of proof falls disproportionately on challengers. This double standard became glaring when geopolymer theory gained traction. Lab analyses of pyramid stones revealed synthetic markers, yet the response wasn't curiosity, it was dismissal. Only after decades of peer-reviewed studies has the idea begun gaining cautious acceptance. Underlying these debates is a deeper fear: the collapse of historical hierarchies. For centuries, Western academia framed civilization as a linear progression from primitive to advanced, with Europe at the apex. Megalithic wonders in Africa, the Americas, and Asia disrupt that narrative. When the Nabta-Playa stone circles in Egypt predate Stonehenge by millennia, or when the Mohenjo-Daro site in India reveals urban planning rivaling Rome, it challenges the Eurocentric timeline. The backlash isn't always overt, but it's palpable, like the decades it took to acknowledge that the Olmecs, not the Maya, pioneered Mesoamerican writing. Yet change is coming. Younger archaeologists, armed with LiDAR scans and particle physics, are questioning old dogmas. The discovery of a hidden chamber in the Great Pyramid using cosmic ray imaging proves that even the most studied sites hold secrets. As tools improve, so does our humility. The real crisis isn't anomalous evidence, it's the reluctance to admit how much we don't know. After all, if a single site like Gerbeckly Teep could rewrite history, what might the next discovery reveal? The stones aren't just relics of the past, they're mirrors reflecting our own biases back at us. And sometimes the hardest truth to uncover isn't buried in the earth, it's woven into the stories we've told ourselves for centuries. The towering walls of Sacsayhuaman, still standing strong after centuries of earthquakes, hold more than just historical intrigue. They offer a masterclass in sustainable engineering. Unlike modern concrete, which crumbles under seismic stress, the Incas' polygonal masonry flexes and settles, dissipating energy like a living organism. Today, as architects grapple with climate change and resource scarcity, these ancient techniques are experiencing an unexpected revival. In Japan, engineers studying the seismic resilience of Machu Picchu's terraces have incorporated similar dry stack principles into skyscraper designs, creating buildings that sway rather than snap during tremors. Meanwhile, in the Netherlands, researchers are experimenting with self-healing concrete inspired by Roman recipes, mixing volcanic ash to mimic the Pantheon's millennia-old durability. The past isn't just a relic, it's a blueprint. Consider the energy efficiency hidden in these structures. The Great Pyramid's alignment isn't just astronomically precise. Its north-facing entrance and internal air shafts create natural ventilation, maintaining a constant temperature despite the desert's extremes. Modern passive cooling systems, from Bahrain's wind-catching towers to Arizona's earth-sheltered homes, echo this ancient wisdom. Even the materials tell a story. While contemporary construction guzzles carbon-emitting cement, megalithic builders used local stone, often repurposing glacial boulders or quarrying on-site to minimize transport. The Coral Castle's enigmatic creator, Edward Leedskalnin, allegedly moved tons of rock alone using counterweights and balance, principles now inspiring zero-energy crane designs. Perhaps the most profound lesson lies in their collaborative spirit. Gerbeckly Teep, built before the wheel or metal tools, required thousands of workers coordinating over generations, a testament to communal effort without centralized authority. Contemporary projects like the Barefoot College in India, where villagers train as solar engineers, prove that decentralized knowledge sharing can tackle global challenges. Even the acoustic properties of ancient sites, from Malta's Hypogeum to Chavin de Huanta's Whispering Galleries, hint at technologies harnessing natural resonance, a concept revived in today's sound wave-based medical treatments and vibration-dampening bridges. The irony is striking. As we race toward AI and smart cities, the solutions to our most pressing problems might be carved in stone by hands we once called primitive. Their legacy isn't just in the monuments they left, but in the questions they force us to ask. What if sustainability isn't about inventing new materials, but rediscovering old harmonies? What if resilience isn't about dominating nature, but collaborating with it? The megaliths don't just stand as ruins, they stand as mentors waiting for us to relearn the language of earth and sky. Despite decades of study, the megalithic wonders of our world still guard their most profound secrets like silent sentinels. Take the puzzling tool marks found on granite blocks in Egypt's Valley Temple grooves, so precise and uniform. They resemble the work of modern machining equipment rather than copper chisels. Then there's the enigma of missing logistics. At Baalbek, where 1,000-ton stones were hauled uphill, archaeologists have yet to find any traces of the ramps, sledges, or worker camps required for such Herculean efforts. It's as if these stones simply floated into place, leaving no paper trail in the form of rubble or tool fragments. The gaps in our understanding aren't just about how these feats were achieved, but why with such obsessive precision. Consider the Moai statues of Easter Island, their towering forms carved with exacting detail down to the spinal vertebrae etched into their backs. Yet many were transported miles across jagged terrain, only to be placed on ceremonial platforms facing inland, away from the ocean. What compelled this level of effort for a seemingly symbolic gesture? Similarly, the Nazca lines etched into Peru's desert over 2,000 years ago reveal geometric perfection visible only from the air, a perspective impossible for their creators to witness. Were these meant as messages to the heavens, or do they encode something we've yet to decipher? Emerging technologies are finally offering glimpses behind the curtain. LiDAR scans have peeled back jungle canopies to expose sprawling megalithic networks in Cambodia and the Amazon, proving entire cities lay hidden beneath vegetation. In Turkey, ground-penetrating radar recently detected a hidden chamber beneath the Neolithic site of Karahan Teep, its walls adorned with unreadable symbols. Meanwhile, 3D modeling has uncovered something startling at Stonehenge. Microscopic wear patterns on the bluestones suggest they were hauled not on rollers, but atop a conveyor belt of wooden posts, a technique previously undocumented in ancient Europe. The most promising breakthroughs, however, may come from materials science. Researchers analyzing stone samples from Puma Punku discovered traces of organic compounds, hinting at the possible use of plant-based solvents to soften rock. In Egypt, a team using muon tomography, a cosmic ray imaging technique, detected unexplained voids near the Great Pyramid's entrance, reigniting debates about hidden chambers. Even AI is joining the hunt, with machine learning algorithms scanning thousands of carvings at Gerbeckly Teep to decode recurring patterns that might represent an early form of writing. Yet for every answer, new questions emerge. Why do so many megalithic sites share nearly identical celestial alignments despite being continents apart? How did cultures without shared languages or contact arrive at such similar solutions? The stones remain silent, but the tools to hear them are finally within our grasp. As drones map inaccessible cliffs and quantum sensors detect buried artifacts without excavation, we stand on the brink of revelations that could rewrite not just chapters of history, but entire volumes. The mystery isn't fading with time, it's unfolding, and the next discovery might lie just beneath our feet, waiting for the right technology or the right pair of eyes to bring it into the light. From celestial alignments to lost technologies, the megalithic wonders scattered across our planet aren't just relics of the past, they're mirrors reflecting the gaps in our understanding. Consider this: the Great Pyramid's base is level 2 within just 15 millimeters across its entire 13-acre footprint. Modern builders, armed with laser levels and GPS, would struggle to match that precision. And yet, we're told these feats were achieved with nothing more than copper chisels and ropes. The dissonance between mainstream narratives and the physical evidence is impossible to ignore. What makes these structures so captivating isn't just their scale or age, it's the lingering sense that their builders possessed a harmony with the natural world that we've since lost. The Inca didn't fight earthquakes, they designed walls that danced with them. The architects of Newgrange didn't just observe the winter solstice, they wove it into the very fabric of their tomb, turning stone into a celestial timekeeper. These weren't random acts of engineering. They were conversations with the earth, the stars, and forces we're only beginning to measure. The true mystery isn't whether ancient cultures were capable of such feats the stones prove they were. It's why we're so resistant to re-examining the stories we've been told. For every orthodox explanation that crumbles under scrutiny, there's a chorus of voices dismissing alternatives as fringe, even when the evidence demands reconsideration. Take the vitrified stone walls of Scotland's Iron Age forts, fused by heat so intense it rivals modern blast furnaces, or the drilled cores extracted from Egyptian granite, their spiral grooves suggesting machinery we've never found. These anomalies aren't outliers, they're breadcrumbs leading to a forgotten chapter of human innovation. Perhaps the most humbling realization is that decoding these secrets might require more than just new tools. It demands a shift in perspective. Indigenous traditions from the Andes to Australia speak of ancestors who listened to the Song of Stones, shaping them not through brute force but by understanding their intrinsic nature. Modern physics confirms that everything vibrates at a quantum level. Could the ancients have harnessed this principle in ways we're only now glimpsing? As laser scans reveal hidden chambers and AI deciphers long-forgotten symbols, we stand on the brink of discoveries that could rewrite history. But the greatest lesson these megaliths offer isn't about the past, it's about the future. They remind us that human potential isn't linear, that brilliance can emerge in any era, and that the Earth itself holds knowledge for those willing to listen. The stones have waited thousands of years for us to catch up. The question is, are we ready to hear what they've been trying to tell us?